In this video, we're going to go over area of a sector, and it's going to be another short video, but first we're going to talk about how it ties in from geometry. So in the textbook, it says, recall from geometry that a sector of a circle is a region bounded by a central angle and its intercepted arc. For example, the shaded portion in the figure, this picture right here, is a sector of circle P. The ratio of the area of a sector to the area of a whole circle is equivalent to the ratio of the corresponding arc length to the circumference of the circle. All right, let's go back because that sentence sounds so confusing. So the first part, the ratio of the area of a sector, which is A, to the area of a whole circle, the formula for it is pi r squared. That's from geometry. So what I'm talking about ratio is this fraction right here. A, so basically area of a sector of or over the area of a whole circle, which is pi r squared. Make sure you follow along with the given illustration here. So area of a sector is A over area of a circle, which is pi r squared. Now continue with the same sentence. The ratio of the area of a sector to the area of a whole circle is equal to the ratio, meaning another fraction, of the corresponding arc length to the circumference of the circle. So corresponding arc length, talking about this part right here, length of QRS. Basically the arc length of QRS over the circumference of the circle. Here's the formula for circumference of the circle, 2 pi r. So basically it's saying that the ratio of area of sector over area of a circle is equal to the length of QRS, or the arc length of QRS, over 2 pi r, the circumference of the circle. Now, looking at this picture, when it says finding area of a sector, it's just meaning finding the area of a certain part of the circle, a certain section, meaning that you're not finding the area of the whole circle, just looking at a certain part of the circle and then just finding that area. Not the whole circle, just a certain part of it. That's what area of a sector means. So you can see from this illustration that we're basically finding the area of the shaded region. Now, how does the ratio of area of a sector to the area of a whole circle and the ratio of the corresponding arc length to the circumference of the circle ties into area of a sector? So basically, it's using the ratios where the length of QRS is basically being replaced by the formula of arc length, which is r theta, as said right here. The length of QRS is r theta, radius times the central angle. So once that's replaced, what happened here is the mathematical operation was used to get A by itself, which will be shown later on. Once A is by itself, it is set to equal to 1/2 r squared theta. So the concept of, or the definition of, area of a sector is the area A of a sector of a circle with radius r and central angle theta is A equal 1/2 times r squared times central angle theta, which here's a given picture, and where central angle theta is measured in radians. So same thing with arc length. When you're doing area of a sector, your answer should come out in radians. Now, if it's given in degrees, follow the rule how to convert to radians. Now, if the question asks you, find the area of sector in degrees, that means that your answer will come out in degrees. So once you find your area of a sector, simply convert it to degrees. So again, if you're just looking for a specific area of a sector, you just follow this formula. A equals 1/2 times r squared times central angle theta.